This conference will now be recorded.
Can I start once again? Okay, today we are okay guys, today we are seeing a portal frames with a side sway. Okay, so side sway means the lateral movement of the frame is termed as side sway. Okay, so what are all the reasons which causing the frame to move lateral direction? Okay, so the first reason is eccentric or unsymmetrical loading of the portal frames. Okay, if the loadings on the frame is eccentrically placed or unsymmetrical loaded means the frames tends to sway. Okay, tends to occur sway. Second reason is the unsymmetrical shape of the frames. Okay, the shape of the frames is an unsymmetrical means the sway will occur. Third, the different end conditions of the columns. Okay, the end conditions are differed means sway will occur. Fourth one, non-uniform sections of the members. Okay, the moment of inertia value is getting differed means sway will occur. Then horizontal loading on the columns. Okay, if the column is nothing but the vertical members. Okay, in frame will mention as columns. Okay, the column denotes the vertical members only. Okay, if the column as loads means okay unsymmetrical load or horizontal loading, if any one column as a load means sway will occur. Sixth one, settlement of the supports of the frame. Okay, any one supports are settled or sinking means sway will occur. And all those reasons, okay, all these 6 reasons combine to cause sway also. Okay, so these are the figures for the 6 reasons. Okay, for 7 reasons also. Last seventh one is the combination of all the 6 reasons. Okay, now we are seeing the most general equation for case one. Okay, we are in different cases. Okay, the case one is we are having loads in both the columns. Okay, that is span AB, span CD. We are having loads in both the columns. Okay, if the case is like this means, so what is the most general equation? Okay, that is shear equation. So in this frame, the unknowns are theta b, theta c. Okay, and one more unknown. Okay, because of the sway, that is delta. Okay, here the delta is the distance moved. Okay, distance moved by sway. Okay, that only. Okay, so for that also we have to derive an equation. Okay, so 3 unknowns, 2 joint equilibrium equations are here. Okay, one more equation we have to find. Okay, that is the shear equation. So shear equation. Okay, we are taking 2 columns only, that is span AB and span CD. In both the span we are assuming the end moments are in clockwise direction. Okay, first we are taking span AB. So in span AB, taking moment about point B. Okay, so because of HA will have moment at point B, so HA into H1. Okay, in anti-clockwise direction only, say anti-clockwise moment, so minus HA into H1 plus clockwise moment MAB plus MBA, both the moments. And we are having one more load P. Okay, so because of this load we'll have anti-clockwise moment only. Okay, P into H, so minus P into H is equal to 0. Okay, on solving this we'll get HA is equal to MAB plus MBA minus P into H, the whole thing divided by H1. Okay, next we are taking for the span CD. Okay, for span CD, taking moment about point C. Okay, so as like span AB. Okay, because of HD we'll have a moment at point C. Okay, anti-clockwise moment, so minus HD into H2 plus MDC. Okay, moments at the supports, MDC plus MCD. And we are having UDL load in span C. Okay, because of UDL we'll have clockwise moment at point C. Okay, so UDL into distance by 2. So UDL value is W. So W into H2 by 2. Okay, W plus W into H2 by 2 is equal to 0. So on solving this, okay, we'll get HD is equal to MDC plus MCD plus WH2 square by 2, the whole thing divided by H2. Okay, we'll get 2 equations, HA, HD. Okay, and we know summation h is equal to 0. Summation h is equal to 0, nothing but summation of horizontal forces. Okay, so in the problem, okay, so the horizontal forces are, okay, so at the support a is a fixed support, so we'll have a fixed support means three reactions will act. Okay, so one is a vertical reaction, another one is horizontal reaction, and third one is moment. Similarly, support d also fixed support, so we'll have three reactions. Okay, vertical, horizontal, moment. Okay, so here we have to take horizontal reaction only because we are solving horizontally only. Summation h is equal to 0, so ha will come at point a, at point d, and we are having horizontal force and in the span AB also, that is P. Okay, and one more horizontal load, okay, lateral load, UDL is also there. Okay, UDL is acting in opposite direction. So summation h is equal to 0, HA plus HD. So okay, HA and HD are acting towards right side direction only. HA, HD, so plus only HA plus HD plus P. P is another horizontal load in span AB that is also acting in right side direction. So we have to take it that as a positive. Next, minus WH2. Okay, so this is because of UDL. UDL is acting in opposite direction. So minus WH2. Okay, UDL, we have to consider this as a total load. So load into distance, WH2 is equal to 0. Okay, this is the equation. We know HA, HD and all. Okay, HA, HD only we calculated. Okay, we are substituting those equations. Okay, so HA is MAB plus MBA minus PH divided by the whole thing divided by H1. Similarly, plus HD. HD is MDC plus MCD plus WH2 square divided by 2, the whole thing divided by H2. Okay, so these two terms are in positive direction. Okay, that is in right side direction. Okay, HA plus HD plus P. Okay, plus P minus WH2 is equal to 0. Okay, so this is the most general form of equation. Okay, for shear. Okay, because of this way, this equation we have to use. Okay, so now three unknowns, theta b, theta c, and delta, and we are having three equations, two joint equilibrium equation and one more shear equation. So we can solve the problem easily. Do you have any doubts, Manisha?
Yes, sir. No, sir.
This conference will now be recorded.
So next we'll see case 2. Okay, so case 2 is a frame. Okay, in that we are having only one load. Okay, in span AB. Okay, in case 2. Okay, so that is also frame. Frame means three members A, B, B, C, C, D. Okay, so in that column A, B has only loads. Okay, case 1, both the column has loads, but in case 2, only the column AB has loads. It may be UDL or a point load or some other loads. Okay, so this type of problem comes under case 2. Okay, so the equation is, general form of equation, shear equation is MAB plus MBA minus, okay, so same what we see in the case 1. Okay, if the column AB as load, okay, that load is acting towards left side direction means we'll have minus symbol. So minus, okay, load into distance, that is up to point B. Okay, here we are having UDL, so minus W into H1 into H1 divided by 2. Okay, that only the road here, minus W into H1 square by 2, the whole thing divided by H1. Okay, similarly what we saw in case 1. Okay, plus next plus for column CD. Okay, for column CD the moment is MDC plus MCD. Okay, both the end moments. Okay, adjoin D MDC, adjoin C MCD. Okay, the whole thing divided by H2. Okay, if the column CD also has a load means because of that load, okay, we'll have a moment at point C. Okay, that moment also will come here, but we are having no loads in column CD, so we don't have moments. Okay, only the end moments only we are coming here. MDC plus MCD by H2, the whole thing divided by H2 plus here we are having a load at span AB. Okay, so because of this load, the moment. Okay, plus W into H1. Okay, total load. They wrote the total load plus W into H1 is the total load. Okay, similarly, what we saw in case 1. In case 1, you see here, case 1, the final general form of equation is MAB plus MBA. Okay, so these are the n moments, MAB plus MBA minus PH. Okay, we are having a load P and span AB. So because of this load, minus PH divided by the whole thing divided by H1. Okay, the same like case 1 only here also. Okay, in case 2 also MAB plus MBA minus, here we are having UDL. Okay, so minus WH1 square by 2, the whole thing divided by H1. Okay, and next for column CD, okay, the n moments MDC plus MCD plus a moment because of the load in the span CD. Here we are having UDL load. Okay, so because of this UDL load, moment at point C is W into H2 square by 2, the whole thing divided by 2, H2. Okay, but in case 2, okay, we are having no loads in CD. Okay, so only the n moments will coming. MDC plus MCD, the whole thing divided by H2. Okay, plus the load acting on the span AB. So total load acting in span AB is W into H1 is equal to 0.
This conference will now be recorded.
Okay, now we'll see the case 3. So case 3, we don't have any loads in span AB and span CD. We are having load, okay, only one load, that is P acting at joint B only. Okay, so the most general form of equation, shear equation is MAB. Okay, for span AB, the n moments will come MAB plus MBA by H1. Okay, plus, and for column CD, the n moments only will come MDC plus MCD divided by H2 plus P. Okay, so we are having a load, okay, a joint P only, a joint B only. So because of that load, okay, that load is coming plus P equal to 0. Okay, this is the shear equation for case 3. Okay, and for case 4, so case 4, we don't have any loads in span AB and in also span CD. Even in the joints also we don't have loads. Okay, only we are having a load in the horizontal span BC only. Okay, then what will be the most general form of equation or shear equation is MAB plus MBA divided by H1, MCD plus MDC plus H2 equal to 0. Okay, that is the most general form of equation. Okay, here. Okay, so in case 4, there is no lateral load on AB and CD. Okay, so the shear equation is MAB plus MBA by H1 plus MDC plus MCD by H2 is equal to 0. Okay, and case 5. Okay, in case 5, the column AB has no load. Okay, column CD has only the load. Okay, so the equation is MAB plus MBA by H1. Okay, for column AB, and for column CD, okay, MCD will come. Okay, C join C, the moment, two moments will be there, one for span BC, that is MCB, and another moment for span CD, that is MCD. Okay, so MCD will come, and join D is a injet joint. Okay, so here the end supports are getting different. Okay, join A is fixed support, join D is injet support. Okay, so there will be no moment at joint D. Okay, so MCD will come, MCD, and we are having a load, okay, in span CD. Because of that load, we'll have a moment at point C. Okay, so plus P into H. Okay, so plus PH divided by H2 minus P. Okay, because of this load minus P. Okay, this is the shear equation for case 5.